So in this problem, we have to find the domain and range of the given function of two variables, and later we have to sketch the graph of the function. So the given function of two variables is f is equal to square root of 9 minus x squared minus y squared. Let the value of the function at any point xy be z. Now how do we define the domain of a function of two variables? Suppose D be the represent the domain. So domain will be the collection of all ordered pair xy in xy plane, in two-dimensional plane, such that the z equals to 1 minus x 9 minus x square minus y square is well-defined real number. What is the meaning of well-defined? So z value should not come in the form say 1 over 0, because this expression is not defined in mathematics. What does it mean by real number? So we know that square root of a negative number is a complex number, right? So the expression under this square root should always be a non-negative number, that is greater than equals to 0. Now in this case, when will be z a well-defined real number? If this 9 minus x square minus y square is greater than is equal to 0. Let us simplify it. This implies 9 is greater than equals to x square plus y square. And this is basically x square plus y square is less than equals to 9. So only those xy plane in xy points in xy plane which satisfy this inequality will be part of that domain, right? And we can see that this one is nothing but a disk. So if we plot it here in xy plane, so this one will be this is circle, right? And this one, this shows this is shaded program including the boundary. This shows x square plus y square is less than equals to 9. Or we can say x takes value from minus 3 to 3 and y takes value from 3 to minus 3 to 3. So this can be solved as x is between minus 3 to 3, y is taking value from minus 3 to 3. So the domain of the function will be, this is collection of all xy point in the xy plane such that minus x is taking values in this closed interval minus 3 to 3, and y coordinate is also taking values from minus 3 to 3. Now coming to the range of this function. How is range of a function defined? Is a collection of all z values along the real number line. Okay, it's only one dimensional, such that of course z takes values from this rule, z equals to 9 minus x square minus y square, but we should also consider here that x is x taking values from interval, close interval minus 3 to 3, and y taking values again from interval minus 3 to 3. Now how will we find what will be the z interval? Now let us see, we have z equals to square root of 9 minus x square minus y square. Now square root function is always a non-negative function. So one thing is sure, z belongs to the interval 0 to infinity. Now the next question is, does z take all the values in this interval? So now again coming back to the rule of the function. What will be the maximum value of z? Z will be maximum when the expression on the right hand side is maximum. And when will be this expression maximum? When the variable quantity x square minus y square is minimum. So we can write it as square root of 9 minus x squared plus y squared. What will be the minimum value of x square plus y square? It will be 0. So what will be the maximum value of z? It will be square root of 9 minus 0, and this one will be 3. what will be the minimum value of z. Okay, so what will be the minimum value of z when the expression on the right hand side is minimum? And when will be this minimum? The minimum value will be when x square plus y square is maximum. And what is the maximum value of x square plus y square? It's 9. Okay, so z minimum will be 9 minus 9, and this one will be 0. So range of the function is z minimum, that is interval 0 to 3. So the range of the function will be close interval 0, 3. Next, we have to sketch the graph of this function, right? And which geometrically we say surface. Okay, now let us first see what is graph of a function, how graph of a function is defined. Graph of function is collection of all x, y, z points in three-dimensional space such that x, y couplet takes values from the domain, where domain is given above, and z takes values from the range set, and the range set is 0 to 3, close interval 0 to 3. Now one way of doing it is finding all these x, y, z values, then locating these points in space, in three-dimensional space, then joining all these points to sketch the surface, right? But this is easier to say than done because there are infinite many such xyz points. But in this case, the given function geometrically represent a standard surface. So the rule is z equals to square root of 9 minus x square minus y square. Now let us square it both sides. This becomes z square equals to 9 minus x square minus y square. Further simplify it, bring minus x square and minus y square to left hand side. So this become x square plus y square plus z square equals to 9. And we know that this is the equation of a sphere with center at origin 0, 0, 0, and its radius is equals to 3. And our function, our surface is not the complete sphere. It is only one branch, the part it will be a hemisphere. So let us have some drawing lessons. We will first sketch this sphere in the three-dimensional coordinate system, and then get the sketch of the given function in the form of a hemisphere. So this is a y-axis, this is z-axis, and since these axes are making a perfect 90 degree, okay, it means the screen of our digital device is in YZ plane. And now we are making a 3D coordinate system in a plane. So the x-axis will be slightly tilted, and this one is our x-axis. Now consider here this equation of a sphere. In YZ plane, x coordinate will be 0. So the cut by the YZ plane, okay, on this sphere will give us a circle. We will put x equal to 0. It will give us a circle y square plus z square equals to 9. It will be a circle in YZ plane with the center at origin and radius as 3. So let us take a yellow color. So this will be a perfect looking circle in please forgive me for my sketches. So this one is a circle cut by the YZ plane, that is x equals to 0 from the sphere. Another circle, if we put here y equals to 0, it will be a circle in xz plane. So we have xz plane is like this, so another circle will be, this is cut by the xz plane. So this is the second circle. And the third circle in xy plane, if we put z equals to 0, so xy plane will cut this sphere into sphere x square into circle x square plus y square equal to 9. So this is our third circle. All these three circles are cut by the three planes, three coordinate planes. These are the curves of intersection of this sphere by the three planes. So this one is our complete sphere x square plus y square plus z square, right? Now this is made by two hemisphere. One is above z y xy plane and another one is below xy plane. Okay, so above xy planes means z will have positive values and our function has z equals to only positive values, right? So our diagram will be, our sketch of the graph of this function will be this hemisphere only, this hemisphere. So we are giving it this red color, this hemisphere, surface of this hemisphere. This one is the graph of the, is the sketch or graph of the given function of two variable. Okay,